Hi, my name is Fred. Welcome to the Epic Endurance Podcast, where we take a deep dive into strength, endurance, and conditioning. Today, we're going to talk about how to maximize the efficiency on your bike by looking at factors like your rolling resistance, but mostly by looking at your CDA, the amount of air that is slowing you down. In a previous video, we talked about how to estimate your finish time based on power, and there were a couple of factors that played, namely your rolling resistance and your CDA, which is the coefficient of aerodynamic drag, or the amount of air that you're taking in the face that is slowing you down. And there was also the drivetrain efficiency. Today we're going to talk a bit about these three. The main focus is going to be on CDA, but basically these three factors that you can control and also affect your speed, how to go a little faster, a little smarter. First, we'll talk about drivetrain efficiency, and drivetrain efficiency is mostly linked to a couple of factors. How clean is your chain, or if it's worn out chain might not transfer the same amount of power. How well aligned is your front cog and your back cogs on your cassette. So if you do cross chain and you're maybe staying on the big ring on the front and the biggest ring on the back, your chain might be misaligned and not in a straight line, and this will also impair power transfer, so some energy will be lost there. You'll also have things like wheels that are not true, that might not be directly a drivetrain efficiency, but I might as well include it into this. So if your wheel is wobbly because it's not being fixed properly, these things also might result into a loss of power transfer. Drivetrain efficiency is usually at 98% when the things are working correctly, but if you have a dirty chain, if everything is wrong, then it can go down to about 90%, so some energy will be lost there, and this is something that if you take care of your bike and if you look after things, is an easy fix. So that's number one. Number two, we're talking about CRR, or the coefficient of rolling resistance, which is the amount of energy that is being lost while your wheel is turning on the ground. So there's going to be a minimal amount of energy which is coming from the friction on the ground. This is mostly affected by the kind of tire you're using, so the width, the size, the component, the quality of the tire. Some tires that are softer or harder might react differently and therefore lose more or less energy. The tire pressure, if it's not put properly, I did put another video about tire pressure and trying to find this optimal range based on your weight and the condition outside, so I do recommend checking this out. There are a couple of ways to look at CR. The simplest way will just be to go by tests that have been done online. So their website that specialized into testing tires under different conditions, and you can rely on these. They are subjectively accurate for most times. They will test a wide variety of tires. Another way is if you do have all other metrics, so if you know all other variables, then you can estimate CR based on the fact that you know everything else. So if you know how fast you're going, you know how much power you're having, if you know the condition, if you know your aerodynamic drag because you've tested it or you're testing it with something, then you can just assume what is your CR. Now, CR variations are not huge, but they can play among a few watts. So looking at optimizing CR this way is really for advanced cyclists. However, it might be something that you want to do. In this case, that will require testing. Is something that I do, but testing on the outside. If you cannot do that for whatever reason, then I would just recommend going through different websites and checking what is the estimated CR, knowing that some riders are different weight, the tires might react slightly differently, and in a minute, that would be it for CRR. CR might account for 5 to 10 watt lost if you're doing things okay, and if you're on a very poor surface, because surface condition will also matter, then you can lose up to 20-30 watts, but we're talking about very, very demanding courses. Last but not least is going to be CDA, your coefficient of aerodynamic drag. which is one of the most important factor. The adage "aero is everything" is extremely relevant, especially for cyclists that do want to go fast. Aerodynamic resistance will be impacted by primarily your posture on the bike. So despite of what you might see on magazines, you are the biggest object that's traveling through space, and you're the object that's catching most of the wind. So if you can change your posture, then you will drastically affect this aerodynamic resistance, and therefore either slow you down or help you go faster at the same power output. Rider frame, so CDA does not really care about how heavy you are. Your weight will more impact your ability to climb uphill and also affects the speed at which you can go downhill. But your body density, the volume that you're taking into space, like we're saying, is going to affect your CDA. So if you were a rider with a smaller frame, then you will be catching less wind, and most likely your CDA will be going lower. Clothing is something which is often put aside. Clothing do account to quite a bit. Tight-fitted clothes that do not catch wind will allow you to go faster, whereas jerseys with pockets or loose clothing will slow you down. It is no mistake that people are aiming to buy things like aero socks. These might seem silly, but optimizing your clothing setup might save you 10-20 watts with minimal adjustment. If you're doing something crazy and you're wearing like a scarf, then obviously the numbers are going to be much higher, but clothing can account to quite a bit. Next is helmets. Aero helmets compared to normal helmets also will direct the flow of air in a different direction and will improve your CDA. Your bike setup, so this is how is your front setup, like if your arms are placed a little higher if you're in a TT position, or lower if you are having water bottles, where are these water bottles, what shape are they, all of these are going to affect. And what works for one person is, despite of what people tend to assume, not always working for everyone, and there is a reason for that. I don't know if you know this kind of silly YouTube advertisement where you have some water leaking of tubes and you're trying to find which bucket is going to be filled first, and you have holes in these tubes. Well, air flows, I must say, in the same way, and since we have different body shapes and we might have different front setup, then the direction of air is going to be redirected in different ways. There are big principles in adjusting your posture and your setup, but ultimately there is a big individuality component when it comes to fine-tuning. So your bike setup is going to play. Then will be bike design. Some bikes are designed to go a little faster because they catch wind less, so their frame maybe is shaped in a non-spherical manner, as a way that the airflow just goes smoothly around the structures of the bike without disruptions. These are helpful, but this is not what impacts you the most. Like we say, your posture will be number one. Wheels, the same way. Turbulences can be affecting your speed, and deeper rims will allow you to travel faster, given that you don't have any strong crosswinds. But generally speaking, they're faster, less stable. The deeper the rim, then the less stable when we have crosswinds, but often the faster you'll tend to go. Air density, this is something that you cannot fully control, so the altitude and temperature will affect how dense is the air. If you were to race at 5,000 meters above sea level, then you'll find that for the same power you'll be able to go very, very fast. Obviously you might feel very, very tired, but air density, racing condition will affect CDA, and of course the wind. Now with air density and wind, if you're in a race and if you're being punished by these, then everyone else is, and therefore if you're doing everything else right, then you'll probably be punished a little less. If we look at riders, when we're looking at CDA again, you'll see that drafting, riding behind other riders or any other vehicle, for instance, does impact your CDA very much. That is why in most of triathlon races, drafting is illegal, as it will give an unfair advantage to most riders. Riding in a peloton is very, very beneficial for people that are in the back or in the middle of the peloton. The front rider will be taking most of the wind. You can achieve speed 30% below your normal power, so this can be a huge advantage. Now, the drafting distance that is often given into triathlon races of give or take 12 meters depending on the race, this non-drafting zone, even being outside of this drafting zone, will give you a small advantage. So knowing your drafting zones in a race and staying just on the edge of this zone is probably going to help you go faster. They do have drafting legal events in short distance triathlon like sprint or Olympic in different formats. These are often done without TT bars. In this case, then drafting is extremely important, as if you end up riding alone, then you get dropped out by everyone else because everyone else will go very, very fast in short distance triathlon. Therefore, transition time is extremely important, as missing transition by 1 or 2 seconds will create a gap on the bike and things kind of cascade from there. So CDA is impacted by your bike setup, and I don't know how much experience you have into triathlon. Have you seen paratriathletes? In paratriathlon, the handy cycles are again powered only by hand and also have a very low profile. Now these are different from recumbent bike, which are bicycle put flat and the people can use their legs to power themselves and also allow for very fast speed. But handy cycles athletes achieve relatively high speed by maintaining a very low CDA while having to output a bit less power than people with their legs. I want to take a quick look at calculator made for your CDA. Very, very handy. This is quite reliable if you can repeat the test a few times. So I would recommend when you do try to gather your CDA that you run segments of a course in both directions a couple of times and then you take averages. Now this is not going to be as instantaneous as having access to, for example, a wind tunnel, which is difficult for most people and expensive as well, or testing in person with a coach like me and then doing an outdoor test and looking at CDA with equipment and then trying to fine-tune the adjustment and seeing in real time how does it impact your CDA, also on segments. So this is called CDA estimate. Here you will input your preferred unit, then the altitude. Like I said, the altitude is going to impact the both air pressure and density, the temperature. So all this is going to, if you know and you have an application you want to override the air pressure, you can do that. Otherwise, we use other metrics. Your weight, the clothing that you're carrying. So how much gear, how much is if you're carrying bowl. Now you can input your weight, clothes gear, bike weight, the distance you're traveling, the total climb. So if you have been climbing 100 meters over the course of 30 kilometers, we can change this, for example, and your finish time. Now I'm going to play a bit with this and input a weight of, let's say I'm going back to 78 kilos and my bike is maybe 8, and clothing gear maybe 1 kilo. I'm trying to do 40 kilometers into, when you say a completely flat course, because I'm lucky, and I want to finish this into, let's say, 50 minutes. Drivetrain efficiency has been set to 98%. There is no wind. Perfect. Rolling resistance 225, which is a very, very good rolling resistance. If you go back to the calculator before, the one about finishing race time, then you can also have another description of rolling resistance, but 0025 is a very, very good rolling resistance. We have my power output. Now obviously going at this speed, 48 kilometers at 113 is not possible, but let's say I am at 310 watts for this duration, and that would require me to have a CDA at 0.195, which is very, very good. So not in the impossible realm, but quite challenging. 0.2 might be a little bit more realistic. Now let's say I want to try the same thing, but let's say the temperature is a little higher, like 25 degrees, not very, very long course, and I'm trying to find a suitable location, maybe at 400 meters of altitude. And I calculate again, and now my CDA is above 0.2. So again, the temperature and your altitude will affect your requirements. I'll be happier if I go at 3, and this is almost doable. So this is a way to look at it. If you do have your CDA number and you've run a couple of tests, then your approximation into calculating your finish time on the bike are going to be more precise. And again, the idea here is really to try to go faster for less work. This will, if you're a cyclist, that might just be the goal. If you're a time trialist, then you know these things. If you are a triathlete, then obviously saving 5, 10, 20 watts will make hell of a difference. If you're going at the same speed on your run, will help you to run fresher. Otherwise, you can try to go faster. So again, if you don't remember, I gave a bit more description of CDA and CR onto the other calculator called the How to Finish. So if you know your CDA and you know your power and you know your environmental condition and you're trying to look for your rolling resistance without having to use extensive equipment, then what you can do is basically just put in all the data that you have and look for the missing variable, which would be your CR. An example that you can find again on the CR calculator, which is really made for people that have access to a real-time CDA calculator, or be sure that their CDA is within a small range of margin. And for example, like here I put 200 meters at 25 degrees. This is a half Ironman course. The climb is going to be 0 because it might have 300-meter climb and 300 meters descent. Same for the wind, the looping course. 2 hours 35, drive train is clean 98%. We have a drag at, let's say, 0.25, pretty good posture on the bike, and we are putting, let's say, 185 watts. If your drag was that good at 0.25 and our power was that, and we actually, this will kind of show us that like there is an issue with tires. If we're riding with good tires and we see this number, then this suggests that there is probably a problem. So maybe our CDA here is too good and it's not our actual. Let's say we got 0.3, then we are getting into a range of more normal. 0.003 or 0.0036 is something which is a bit in the normal range. And any variable that you're going to play with or change is going to affect. So we're putting more power, we're achieving the same speed, therefore there is more resistance. Here it's increasing, and yeah, these numbers are a bit more realistic. Again, this is something you can play with, and that adds to the idea of trying to find where there are marginal improvements into your cycling performance. I hope that this was helpful, that gaining some insight on these 3 factors that are affecting you: your drivetrain efficiency, your CRR, looking at websites, maybe testing different kind of tires on your bike and playing with tire pressure like we mentioned before, and trying to get estimate of your CDA. I hope that these will help you go faster than your friends and make you enjoy riding a bit more, knowing that you understand a bit more the applied principle that do help you get faster. That will be it for today. I'll see you next time. If you have any question, please feel free to reach out. Have a good one.